Good morning, friends. Welcome to Water Resources Engineering class. So, we are dealing with the hydrographs. In the previous lecture, we discussed about what is a hydrograph. Today's lecture again focuses only on the continuation part of yesterday's thing. So, continuation part of yesterday's thing, what I will deal in today's thing is only this part. So, today's lecture mainly focuses on the direct runoff hydrograph. Very important. Each topic is very important, but today's lecture is also a what you call it as an entry into the hydrograph. So, if you thoroughly understand this, definitely you can you can enter into these hydrographs in depth and analyze. So, starting point of this, and it should be very clear to every one of you. So, what is it? So, let me straight away come to the point. So, the topic is direct runoff hydrograph. And what is that? How to obtain the direct runoff hydrograph? How to obtain? What is given to you? Given to you is storm hydrograph. What do you mean by storm hydrograph? Because of a rainfall of 3 hours, 2 hours, 5 hours, because of that rainfall, whatever runoff is there, and that runoff, if you collect it at the outlet point of the catchment, so now if you plot a graph between time versus runoff, that is what we call it as storm hydrograph. A storm hydrograph consists of direct runoff and also the base flow. This is the first thing which we have learned yesterday. So now continuation part of it is how to obtain direct runoff hydrograph from storm hydrograph. So from the given storm hydrograph, find the ordinates of storm hydrograph in discharge units at a given interval of time. So normally they will give you like this, you pattern, you see it. So at minus 6 hours, the flow is 5 meter cube per second. From 0, that means the starting point, the rising limb starting point, at time 0, it is 4. 6 hours, 14, 12 hours, 27, 18 hours, 27. So, this 0, 6, 12, 18, 24, what is that? It is time from the beginning of the storm. Storm may last only for 3 hours, but the runoff continues for so much of time. But here in this problem, if you see it, if the storm is there for 8 hours, because he has given, you see here, 4 hour, 45 mm intensity, 4 hour, 25 mm. So like that a rainfall has occurred. So total 8 hours storm is there. In that, with 2 different intensities, the storm has occurred. For this 8-hour storm, what is the runoff? Runoff is collected over how much period? 60 hours. Because it is continuing after 8 hours also. So, for each of that time period of 6-hour interval, they have given you what is the flow, how much is the runoff that is measured at the outlet. So, this is measured at one point actually. So, that runoff is given. Now what you have to do, take time on x-axis, that means starting point is minus 6, 0, 6, 12 like that if you take it, or otherwise if you are not interested minus 6, so directly you can start with 0. So that means why I am interested in that minus 6 also, to show you the starting point of the hydrograph. So if you understand that, always you can start from 0 and up to 60, you plot actually depending upon this, the stream discharge on y-axis, time interval on x-axis, plot the curve. That is what the storm hydrograph means. So first our job is to plot the storm hydrograph. So for plotting the storm hydrograph, what are the things that you require? Number one is the time interval, right? And number two is what is the discharge values. So from time interval on x-axis and this discharge on y-axis, if you take and plot, you get this. And this storm hydrograph is a result of the 8-hour rainfall which has occurred with two different intensities. That is first thing you should understand. Then next, so our objective is what? First, storm hydrograph plotting. That's what here we have mentioned. Then afterwards, next thing is what? Separate the base flow. How to separate the base flow? Yesterday itself we discussed how to separate the base flow. So where it rises, this is point A, you will write. Then how to get this point B? Actually, point B means runoff ending point. How to get it? So that will be actually, what is the basis? The ending point, what is the basis? The basis is n days. How to get this n days? N days from where? From the peak. From the peak, what? Here the peak is how much? 27. So the peak is happening at what time? 12 hours. So 12 hours this peak is there. From this peak actually n days we should take it. What is that n days? N is equal to 0.83 into a to the power of 0.2. A is 35 kilometers square he has given. For example, in a problem. So 0.83 into a to the power of 0.2. So this much 1.69 days. So which is equivalent to how many hours? Some 40.6 hours. So from 12 actually you put 40.8, you will get this. So put that actually on the recession limb, that particular point. That's all. So now join A to B. Right? After joining A to B, whatever is there below this, this is all what we call it as the base flow, and above is what we call it as direct runoff. So these ordinates, if you take it up to here, up to base flow, they're all called as direct runoff ordinates. So now the graph is between time versus direct runoff ordinates. It is nothing but the direct runoff hydrograph. Right? That is what this today's class lecture is. So now the direct runoff ordinates is equal to storm hydrograph ordinates minus base flow. Clear? Right. Next. Now next important thing is, what is this depth of direct runoff? Depth of direct runoff. Excellent bit. Depth of direct runoff. Depth of direct runoff, how can I get actually? So it is nothing but what is the volume of runoff? Volume of runoff divided by area of catchment. Because this runoff is from the entire catchment. So what is the volume of the runoff divided by area of the catchment? So how to calculate the volume of the runoff? The volume of the runoff means it is nothing but you take actually any of the any method you can take it, find out. So all these ordinates, all these direct runoff ordinates, if you take it and sum them up, that is what I have written, sigma O. And what is the unit of those ordinates actually? The ordinates unit is nothing but actually meter cube per second. So per second, whereas on the x-axis what it is there, time, if you see it, what is the time in hours? So what I am doing, this time interval t I have taken, right? I have to find out only volume. Volume I can find out is nothing but the area of that. How I am finding it out? Sigma of the whole thing into time interval. Time interval is in hours. From hours to the 60 into 60 is what actually? 60 into 60 is nothing but actually converting hours to minutes, minutes to seconds. So it is a meter cube per second into hours, time interval is in hours. So this hours I am converting into 60 into 60 so that I am getting it in terms of seconds. So this seconds plus this seconds will cancel. So finally the output from this numerator is meter cube. That is the understanding. Divided by area of catchment is always in terms of kilometer square. So area kilometer square. Kilometer to meter is 1000. Meter square means 1000. So this actually. So that's what I have written if you see it. A into 10 to the power of 6. Right? Into, now all this if I do it, how much, what is the unit I am getting? Meter cube is the numerator and the denominator is in meter square, because kilometer square to meter square I have converted. So if I cancel, how much, what is I am getting in meters? So that is why that meters I want to convert, I have to convert into what? Actually into centimeters, because never we will express the runoff in terms of meters. We express in centimeters. So my meters to centimeters means what can I do? Then naturally whatever you are getting into 100, if you put it, you are going to get in terms of centimeters. That is what I have done. So this is what basically I have done. So sigma O is sum of the direct runoff ordinates, into T is the time interval, into 60 is to convert into from hours to seconds. A, area is of the catchment. 10 to the power of 6 is to convert kilometer square to meter square, then multiplied. So the whole unit is coming into meters actually. I am converting into centimeters actually. So this is the answer. And if anybody is very difficult, if you feel that to remember all that, at least my request to you is, please remember direct runoff depth in terms of centimeters is equal to 0.36 into sigma O into T by A. That's all. Where sigma O is in terms of meter cube per second, whereas T is in hours, and whereas A is in kilometer square. If you remember that, that is fine for us. Now I take a problem actually. I take a problem and solve. Please listen carefully. What is given to me? This is the data that is given to me. What is the data given to me? Ordinates, 6-hour interval flow, that is given. So based on that, if I plot it, this is how I am going to get. Understood? Over. Then what is the first step? Storm hydrographs are given. What is the second step? Separate the base flow. How to separate the base flow? Starting point you record, end point how you get it? End point is equal to A to the power of 0.2. Unit of A is square kilometers. Put it, this is the thing. So now put it, separate it. How much is the base flow? This. Now storm hydrograph ordinates are this. Now separate, you remove that, suppose remove it, and then whatever ordinates that you are getting, they are nothing but, what are those ordinates? They are nothing but direct runoff ordinates. So that is how we got it. Then the direct runoff ordinate is equal to storm hydrograph ordinate minus base flow. Then how to find out the depth of direct runoff? 0.36 into sigma O into T by A. What is sigma O? Sigma O is nothing but actually it is sum of direct runoff ordinates. What is direct runoff ordinate? Is equal to storm hydrograph ordinates minus base flow. These are the things always you should bring in your mind. And if you calculate it, you will get it. See, one more example I have given here. So this is what is given. Time versus flow is given. Right? Time versus flow I have taken. Then what I have done actually, then find out what is N is equal to. Once N is found, then I found what is base flow. Once base flow is found, directly I subtracted it and I got the direct runoff ordinates. Once direct runoff ordinates are obtained, you can find out depth of basically it is depth of direct runoff is equal to you can use this formula and straight away find the answer. That is what I have given here. You see, what I have done is there are two methods actually to do it. First one, what is the given thing actually? The given is storm hydrograph ordinates. Storm hydrograph ordinates. Storm hydrograph ordinates means nothing but stream flow in meter cube per second. That is what is given. Right? What is the second thing that is given? Time interval. So what you have done? What is your steps? What you have done? Separate the base flow. If you separate the base flow, what you are going to get? The direct runoff ordinates. So now what you should do? Sigma O you find out. Then T is the time interval. So depth is equal to 0.36 into sigma O into T divided by A centimeters. Calculate that. Or otherwise also you can calculate depth is equal to volume divided by volume divided by area. How to get the volume actually? Now you have the ordinates. Now use the trapezoidal formula because your ordinates are such that if I take it just I draw a hydrograph, this is the hydrograph. Now you have separated the base flow. So now for example these are the ordinates. Am I right? These are the ordinates. I told sum of it and use this and get. That is one method over. The second method is now if you take it, each one if you take it, this is a trapezoidal and this is a trapezoid, this is a trapezoid and this is a trapezoid. Each one is a trapezoidal. Use trapezoidal formula and then get the answer. So use the trapezoidal formula for the volume and then get the volume. So this is what I have done. And this volume divided by area I have put it. Then I got the answer. Or otherwise whatever just now I told you. 0.36 into sigma O into T by A. How to get it? Sigma O I have added it up. Time interval is 6 hours. Area is this. 0.36 sum into this. This is the answer actually. So any method is fine for you. Either this or this. But I always prefer this. So this completes to be some of the first topic of the hydrographs. That means how really in problems we do base flow separation and how we calculate what are the direct runoff ordinates, and similarly how we can calculate the depth of direct runoff. These are the things we worked out in this particular lecture. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.